Railway Conversation with Doc Frank.
Hey, I'm Doc Frank. Welcome to my podcast where every week I'm presenting you authentic, spontaneous and unrehearsed discussions with interesting guests from the rail industry about topics that matter. Make sure you subscribe and tell your friends about it, as this podcast will both educate and entertain them. Thank you for listening. My guest today is Mats Boman from Stockholm in Sweden. Mats represents a company called Prova, and I did interview a colleague of his previously in episode number 9, in case you want to get back to that. That was Gunnar Smith at the time, and it was the double act from Sweden, where I also had Andreas Mortensen on the call. In today's talk, you will see that Mats is a truly global player that is not only active in Sweden or in Northern Europe, not even just in Europe. It's really activity around the world, including North America, with some very interesting interactions, including the New York City subway. The main topic of the conversation really is how to understand how a railway works, not just understanding in the head, but also bringing it down into a model that can be adopted by others, where others can learn about. This is very important when you want to introduce new technology without throwing all the old stuff entirely away. Please enjoy this conversation. Hi, it's Doc Frank here. Real quick, I want to let you know about one of the best CBTC trainings in the world, if not the very best, but you always need to be careful with superlatives. It's the CBTC Kickstarter online course. It consists of 30 video lessons. That's the 3 with the 0. In total, over 11 hours of training content, talking about everything from the basics of CBTC, current standards, the benefits of CBTC, the key functionality of it, the supply industry, application tips and tricks, lessons learned, do's and don'ts, case studies, arguably the most comprehensive training that you can find anywhere on the topic of CBTC. A few additional things that make learning easier for you that you may not find on any other online courses. One of them being an immersion plan that helps guiding you through the training course and progress it in a finite period of time instead of just having it sit there for months and months on end. There is access to an online study group where you can connect with other students who are doing that training course at the time and form learning groups. And after the training, you will not be on your own. There is an alumni community that allows you to ask questions about the course content on an ongoing basis. So it's basically education for life. You can register on my training portal, which is docfranktraining.podia.com/CBTC Kickstarter online 2023. I repeat that, docfranktraining.podia.com/CBTC Kickstarter online 2023. Mats, welcome to the show.
Thanks a lot, Frank. Thanks. It's good to be here, and I'm looking forward to our discussion we'll have during this time.
Thank you. So you are already the second person of your company, which is on my podcast. I've done a previous episode with a couple of people from Sweden, Gunnar Smith, who is a colleague of yours, and also Andreas Mortensen. For anybody interested, this was episode number 9. And we actually met the first time in Melbourne last month at the core conference, because apparently you've been working on some collaboration to do something in the Australian market. So we don't need to go into any confidential detail about this. We had an interesting chat. It wasn't very long. I would have preferred it to be much longer. That's the conversation here, basically an extension of what we've done in Melbourne for a few minutes. We had an interesting talk about the complexity in railways and how you can approach it when you introduce new technology. So maybe you want to pick up the ball from there and just run a bit with it.
Yes, I guess we in Australia and Melbourne could have talked for hours. Like I said, we didn't have the time, of course, but I also enjoyed the conversation we had and where to start. Sort of to give some background, I've been around in railways for 20 years, and Prover as a company, which I now worked on, and I also been working at other companies as well. But Prover as a company it's on a worldwide market and supplying and offering products for supporting railways, both from specification and development and verification. And we work with, over the years, I worked with all the big suppliers, some small as well, and I worked with IMs, infrastructure managers in different countries. And to me, and when we are involved, Prover as a company, it's often when it's complex. It's often when something goes wrong, because then people need to look for new ways and new methods to manage or maintain or develop verifying the system. So this is actually when we get involved. So of course I've seen examples that are bad. I've seen good examples how things are managed and how things are worked and how things are specified. But to be quite frank, there are no standards how to do it, and there's no silver bullet. So it's different approaches, and sort of we have looked and worked and tried to establish our ways to approaching this. And of course, railway as such, to me, the complexity has many sides, and that's of course that's why it's complex. It's one many-sided. It's because it's really built from your local experience. It's all been rising for someone doing this locally, and then now we're in a situation where we try to be on interoperable, harmonize the systems, but who should adapt and who should actually make their changes to make this system interoperable. So of course we have a big challenge in railway how to address this, and that's where more or less I started. And people talk a lot about standardization and how to standardize things, but in reality we are still experiencing old system. We're still in the challenge that the system existing are 25 years, 50 years old in many cases. And so it's very, very hard to address this. And the standardization for ATMS, for example, has been going on for 50 years, more or less. And it's still not the standard in many ways. It's a method. It's a way to address it and a way to be how to communicate. But still, the system are not running in the same way. There's always adaptations needed and always things to be done to actually manage this. So who should take the lead and who should be the driver and who should sort of actually adapt to follow the standard? That's the hard part.
It's really interesting. Yeah, if you say standardization, or people are calling for standardization, what I found in my own experience is that very often the people calling out for standardization, what they have in mind is, I want something standardized and I want the standard to look like my system, right? Yeah. And if everybody, if different railways all have the same idea that to want to pull the standard into their direction, there's no agreement. There cannot be an agreement, or anything that will be agreed is basically just the smallest common denominator. And then you look at the end result and you said, well, why did I need a standard in the first place? Because it doesn't really standardize anything. Yeah. Other than, okay, well, we have a railway and it's going from A to B, and then that's pretty much the content of the standard. So, yeah. And we've seen this before in practice. If I remember when they kicked off the European rail traffic management system in Europe back in the mid-90s, one of the components that they wanted to standardize was the so-called European traffic management layer. So what that was, or what that was meant to be, was a standardization of the traffic management layer, the supervision systems, the traffic management systems. And after a very short period of time, they realized that it was just too hard, too difficult. So they scrapped the entire idea, because every country, every railway had very, very different ways of running their business, of controlling, managing their traffic. And the idea to bring this all together and for all the countries to agree on something that must look very different from what they had before just didn't work. And they still struggle with this. I mean, look at Euro interlocking, for example, which has changed names a few times, but other than that has been going on for more than 20 years without a real practical application. So I think that the main thing in the first place is for a single railway to really create their own standards, like to really understand and specifying. And I think that's probably pretty much where you fit in. Standardizing and understanding their own ways of working, and then looking how much of this can be transferred meaningfully or needs to be transferred into the new world of the new technology. Is that kind of what you found as well?
Yeah, no, of course, sort of, technology is always first. Technology is in the front. It's before the people actually start to understand it. So someone has a good technology. So of course, today we have new technology that is much more advanced than what we have installed. So first we sort of technology is in place, then you need to convince some people. And then when some people are convinced, then you need to convince the organization. And when the organization is convinced, then we can start to talk about standardization. But in railway, we are there's a long life cycle. So this is 25 years later. So setting a standard 25 years later is not really bringing any value, because there's just a new technology out there that will take and should be introduced. So to me, thinking about this, reflecting over it over years, it's more, to me, I don't think we could have one single standard system that are working. And I think it's rather about how to approach it and how to work with it and how to understand the system and how to interface the system between each other. And I more or less not talking about interfacing, more or less talk about an adapter. I think we should look at as being the interface should be an adapter. And a good example for that is the USB-C, that standard. That you say is one standard. In reality, it's actually 14 different protocols, 12 or 14. Because in the end, that small piece, it's communicate between 12 different protocols. So that's more an adapter sort of way to approach it. Because no one at the end of this system like to change the products on the side. Okay, so let's make an adapter that actually adapts this system from the right to this system to the left and the left to the right, and get them all to talk to each other. Then we don't have to change sort of the end products or end solutions, just how we interface and how we adapt. And okay, then we're in a situation where we need to understand how to sort of express this and how to specify these interfaces or these adapters. And this is a bit where Prover comes in, because we have the language and things to express these things. Still, it doesn't set the standard, but it sets a method to actually approach it and how to be able to express same things in different ways. Because the same thing, I mean, how is A talking to B? The traffic management system talking to the interlocking, or the RBC talking to the interlocking, or in CBTC zone controller talking to the different system. They should behave and do what they're good at. They should do their part. The zone controller should do its part. But how it communicates and how it interacts, that is someone else that could solve that. So to me, looking at the industry and where we're at today, we're missing a lack. It's a lack of system integration and how to actually look at this and how to integrate the system. Because today the system is really built, this one connects to this, and that we get to work. But as soon as we sort of introduce a third party, trying to get A, B, and C working together, then we are in a mess. Because then we're lost, because it's hard to get these three parts to talk together. So we need some kind of data lake, ontology, it's called in computer science, to make the system talk to each other, and that is just being explored. And again, that is not a sort of standard way how to solve it today, and I haven't really seen a good example of that yet. But I know there's initiatives for driving that. But that is the approach we are looking at and taking to adapt and work with these different kinds of system. And in reality, these systems are doing the same. They have the same challenge, or say they have not the same challenge, but they have the same. They should do the same. We should move trains. That's really what we should do. We should move a train in one direction. It should be safe, and it should also be moving in a good speed, the capacity. And there's a challenge also between the capacity and the safety, because the whole system is a safety system. It's built on not being failure, not being crashed. So every time we try to push the button to get the train to move, we actually ask the system to be unsafe for a while. That's really what we're trying to do when we move a train here. So the whole approach of having this as a safety system, and then being a sort of being the, what how should I call it? It's the driving is really a sort of unsafe way is really the opposite, the challenge for how the system should behave and working. And in this we have, I think I heard this figure, to move a train, yes, we need to have 100 systems actually saying okay to get this train to move. And of course this is a complex situation, and we don't know how all this system together works and how they interact in detail. It works right now, and we're quite happy when it works right now, and we're very, very hard time to change anywhere here to make this happen. So we're in many ways out of control, because and that's where when it gets complex, because I've seen many projects and phases where we try to install a new system and do some changes, and suddenly something just happened, and that's really when it's complex. So you think you're in control, but suddenly something just happened, and that's really what's the definition of complex system. You don't know how it should behave or when it should behave and how to solve it. Just happens, and that's where everybody stands and doesn't understand, and where's the errors right now and how to address this. This is to me sort of one of the big challenge in where we're at today.
What I've found recently more and more is that the change from a conventional signaling systems with signals and fixed block sections and so on, moving to, say, in the extreme, a moving block system such as CBTC is such a fundamental change that I think one of the best ways to approach this is to have a real step change, to forget about the old stuff as much as possible, and then introduce the new stuff, knowing that this will work in a very, very different way. I sometimes have these funny analogies. So I was just thinking, you come from a car environment, so your entire life was thinking about cars. And now suddenly you come into a water environment where you have these things that work fantastic on water, which are boats. And you say, and you all know about cars. So you say, well, if I put my car on the water and then I make the wheels turning real fast, somehow this must work. But it's going to sink anyway, because it's just not a boat. It's a car. It wasn't meant to swim on water. So it's a bit like a similar thing with the conventional signaling versus CBTC. It's a very different world. And I think where a lot of the problematic comes from is that people only know about the old world, the old conventional signaling system. So this is their entire way of thinking, their entire worldview. And the new system will be looked at through this worldview, through this lens, if you will. And now the trick is, how much of the old stuff can you actually transfer into the new world? And is it just to find a metro system, which to me is the equivalent of this new world with CBTC, to find a metro system which is as similar as possible to the old system, whether that's a solution, or whether it should rather require a complete shift of mindsets from the old to the new. And one example in your area, basically from Copenhagen or from Denmark in general, Denmark has started this huge initiative of introducing ETCS level 2 for the mainline network and CBTC on Copenhagen Metro. And what they did in Denmark, which I found really, really amazing, was that they said, well, we are aware that the new systems will have completely different ways of working than the old signaling systems we used to have in Denmark. So we make a very conscious decision that we take our old rule book and completely throw it away and come up with something entirely new, which is suitable and conducive for this new REVEC technology that we want to apply, ETCS or CBTC. But not very many REVEs do that. They are not that radical. They cling to their old ways of doing things, to their old signaling principles, and as you said, their safety philosophies. Like that, they have spent decades in working out how to make sure that trains are not colliding with each other, that trains can be moved, but they're still reasonably safe.
Yeah.
And they just stick to it. They can't let go. So saying something like, we don't need track circuits anymore, but the trains will know anywhere where they are safely, even better because more precise than the old system. They struggle so much with that mindset shift, right?
Yeah. And you're completely right. And again, we have a lifespan of a project or a system for 25 years. So of course, someone has been around and worked with the system for 25 years. His knowledge, her knowledge is just about this system. And the challenge as a new supplier is to, and what the new supplier is good at, to introduce their system, because they know everything about the new system, new technology. And today you have to convince the old existing sort of system that this new system is replacing the old. There's an example from Rome. When they did Rome, we had the first computerized system in Rome that they had to specify it all in relays, because you need to show that this is actually working the same. Because and of course, when we're doing that and we're forcing us to do that, of course we don't bring all the values in how to build a computerized system compared to relay-based interlocking system, because and that's what's driving the cost. So now they actually duplicate the system. And same when they install the first CBI system at the NYCT in New York. That first CBI system, that they used more relays and their old standard systems because everybody was afraid. So you had to add the old ways of thinking because this new, we don't trust it. So we add some relays. So in the end, there were more relays in that kind of way to be interoperable and safe than the standard relay system. So sort of there's and also, like I say, I also like to throw out the old things in the new, but we haven't really seen that big innovation, so we really can do that. We're still trying to solve the same thing we've been solving in 150, 200 years. We move a box on rails, and this is also a thing that makes it a bit complicated, because talking to someone outside without understanding, it's a quite simple task. We try to move a box in 2 dimensions on one rail. It's not hard. It's not hard compared to flying or automated movement of vehicles, sort of. So we're in a very small and controlled environment, but still we have this kind of challenge. And just understanding that there are challenges. It's very hard to raise to management, upper management, because It's one way quite an easy task we try to perform, but we have over years complicated.
Hi, it's Doc Frank. Real quick. If you are a fan of communications-based train control or short CBTC, there's an event coming up in September that you absolutely don't want to miss. It's the first virtual global CBTC conference. It's called CBTC World Summit 2023, and it's happening on the 20th and the 21st of September. There will be 3 sessions of about 6 hours duration each for 3 different global regions, one for Asia Pacific, one's for North and South America, and one's for Europe and the Middle East. So wherever you are in the world, one of those sessions will be during the daytime in your time zone, and you can watch it live for the full 6 hours with 6 presentations. The kicker about this is that all other presentations, including the ones from your own session, will be available for replay via recordings. So that means that if the other session should be in the middle of your night, you can still watch it on demand at a time that's more convenient for you and doesn't interfere with your good night's sleep. The conference is available for registration right now at my training portal under docfranktraining.podia.com/summit23. I repeat that, docfranktraining.podia.com/summit23. I'm putting a lot of effort into this conference. It will be an absolute blockbuster event, and I very much hope to see you there. I think what's needed is something in the middle, something to bridge the old and the new. So when you were saying that the suppliers should explain how the new system works, I don't think that will work. And the reason why that doesn't work is in the same way that a railway organization coming out of, I don't know, more than 100 years of conventional signaling, they're just thinking in the signaling world. In the same way, a supplier that offers a product like CBTC, for example, they have the same limitations in the realm, in the space of CBTC. So it's a bit like asking someone from, say, China to go to America and teach them Chinese. So the person is not a teacher. So it comes, and I'm just using, you can take any 2 languages that are pretty incompatible in terms of signage and symbols and what have you. So the person from China comes over to the US and he thinks, well, the way to explain the Americans how to talk Chinese is to talk Chinese to them. But these guys don't understand him. They don't understand him. As much he tries to speak Chinese to them, they keep not understanding him to the point where they just give up. It doesn't work. Yeah. So now, but when you introduce CBTC, you can't just give up. You can't say it doesn't work. And what happens very often, which I think is a pretty bad outcome, is they impose the thought models of the old world, a fixed block signaling system, onto the new CBTC. And the outcome is pretty much like a fixed block CBTC system, which is very disappointing in terms of the benefits provided, higher capacity and higher operation reliability, all these kind of things. And then people are disappointed in the new technology, but it's not a problem of the new technology. It's a problem of how to apply the new technology. And if you, if you just impose the old rules on the new system, then this is what it is. Like, for example, if you think you always need to have track circuits to detect trains, and you insist on having a CBTC with an underlying fixed block system, which is what it is if you use track circuits, what do you end up with? You end up with a fixed block CBTC, where nominally you've got CBTC components. They could do moving block, but they're actually not doing it because the system is supposed to use the fixed block systems. So you basically just end up with another fixed block with a new computer in the middle. which performance-wise isn't really what it is. So where I did a lot of research recently is this entire set of mindset, because you need to bring people from the old world over to the new world to understand that for optimum application of something like CBTC, you need to change your thinking fundamentally, because it's a completely different world. Like with this Chinese US example, first of all, you need to learn new symbols for writing, because it all looks very different in the two countries. Yeah. And it's the same thing here. So having somebody understanding the challenge of getting from the old world to a very differently looking new world, and then basically building a bridge. How can I bring people over? Not just explaining this is what the new world look like. And again, that doesn't help, because people listen to the application of the new world, but they're looking at it through the glasses of the old world. So
you're completely right. And again, to me, we don't have those people. You don't have the people that could both understand the old system and the new system. We should have experts on the old system, and we should have experts on the new system. And we shouldn't force neither of them, especially not the new technology, to say that this is how it, and understand the old technology, because then we're stuck in old technology. So the sort of the forcing, it's quite hard to do the forcing. And again, we talked about standards before, and in the end, introducing a new system, yes, you are forced by Senelec or other things to work and follow this standard. And that standard, it doesn't talk about the new technology. It just talks about the old technology and things were done before. So again, you're stuck. The new technology has no room to be introduced here. And I also sort of, I've been driving and talking about a lot of the requirement and how we look at work requirements and how it's worked. So I always ask like this: okay, what's the process for adding a requirement? It's just to write a new one. But then I ask, okay, what's the process for removing requirements? And then you're stuck. There's no process for removing requirement, because removing requirement means that you make something dangerous. It's dangerous to remove requirement because no one actually knows what it means. So what's happened over the years is that we just add the requirements.
Yeah.
So it's just more and more requirements being on top of the system. And of course, that drives costs. So and it drives complexity. So we're in a situation where the system are in many ways overspecified and are forced to comply to old way of thinking, like you say, in requirements and old ways of thinking, because that's what we have today. So we need to get away from that. And you were completely right in the sense that we like the new systems they should bring in the new standards, new specifications, new ways how to do things. That's really what we need to do, and we need to adapt to that and accept that, understand that, without thinking about this is how it really was using in the past. So we need to get to that situation, but it's very, very hard. And I understand we're in a safety system, and the new system is doing the same in a different way. So the leap is in one way too small, because we just try to move trains. That's what we're trying to do. There's nothing else that we're trying to do. Just move trains. So it's not a hard task to do, but it's not a big leap in how the systems are built, and we're trying to do it small steps. So the Big Bang, it doesn't really work neither. We've seen the Big Bang being failed. So the small steps, it's too slow actually to make some change in the end, and we're always behind in terms of the new technology, always in front of us. I haven't found the silver bullet, but I'm trying.
Yeah, I think you mentioned one word which really struck a chord with me, and that was the word trust.
Yeah,
I think part of the problem is that people coming from the old world, they trust in their old system. Why? Because they have been involved in that. It has been developed over decades, And they have basically gained the confidence by working with that old technology over decades that it will work and it will work fine. And they were involved in making sure that it works by having, I don't know, additional requirements and some additional nooks and niches to basically protect against all sorts of exceptional circumstances and so on. So now they have this new technology, which, as you said, does the same thing, like moving trains or enabling the movement of trains from A to B, while at the same time making sure that this train movement is safe, so that trains are not in the same position at the same time, which you don't really want. So, but because the new system achieves the same thing in a very, very different way, the people over here need to develop the trust that these new ways of doing the same thing are equally safe, maybe even safer than the old ways. So, so to me, it comes back again and again to a people issue. The issue, the challenge is between the ears, as they say. It's in people's heads. And there are hidden effects in the background that normally nobody thinks about when they just look at technologies and how do we explain a moving block system to a fixed block fraternity. There can be very other things at stake. For example, let's say you've got a person in roughly my age, so around 60, having worked in railway, starting as an apprentice and having worked in railway for 40 years or more, right? And they have a certain status. They have a certain status as one of the top specialist experts, maybe even call it gurus, for this railway organization in the field of signaling, conventional signaling. Now, all of a sudden, you talk about CBTC, you talk about moving block, you talk about a number of things that the guy over here maybe has heard about, but he doesn't really quite understand it. And now these people over there come in with the knowledge about the new technology. We are very often younger guys, which are already threatening because of the age difference, like the replacement of the old one are the young ones. And so the person over there, the conventional signaling expert, suddenly feels threatened. So he feels the authorities under threat. His status as the super expert in the signaling field is now under threat because his position with regards to the new technology is no longer up here. It's probably rather down there. And there are other people who are nowhere near as good in the old world, are suddenly much better and much more knowledgeable to start with. Better is a relative term, but much more knowledgeable in the new world. And that's a threat. So it could well be that the person over here in the conventional world, by just trying to protect his position, his status, gets offensive, trying to argue a case every time when there is an argument, every time arguing that his view world, his knowledge about how to make a railway safe is the best way there is, full stop. So all the new stuff, if we are lucky, works, but it can never work as well as the old stuff. So this is I think what needs to be addressed. What I'm actually wondering is, you are looking at this problem from I would say from a technical point of view. So you've one of the strengths of Prova, from my understanding, is this thing which is called formal methods, which to me is the attempt of formalizing a body of knowledge and then basically taking this formalized body of knowledge over into the new world. And by doing so, basically convincing the people in the old world that their body of knowledge still lives on in the new world. So, but to me, that's a technical approach, because you're using a technical method of like bridging the two worlds, if you will. How well does this work in your experience? And to what extent do you still have challenges with the mindset of people saying, well, I kind of understand that your methods capture the old word of how I see things. They would never say the old word. They will say the good word, the good way, the good old way, or something like that. So basically, my way of thinking is kind of replicated in these formal methods. Still not quite sure whether that can really be transferred into the new world.
No, but you describe what we're trying to do in a very, very good way. The formal method is about expressing specification system in a formal method, in a mathematical way, in a precise way, and it's also combining with automation and computer science in terms of, yes, we package this knowledge and we work to visualize this knowledge. So what we're trying to do is to realize it and visualize the knowledge. And the old guys I met were many experienced guys that I respect so much, and the work we worked with and were good work with is those guys that are able to actually adapt and understand. And they also many times talked about the challenge of new versus old. In our industry, signaling engineers, experienced signal engineers, if they are in the stage where they're so good and so experienced and so they don't need to protect themselves anymore, because they will keep on working for a long time. And it's more about getting them to understand that, yes, my experience should be kept somewhere. So how do you keep this experience? How do you work with the experience? And getting these guys to sit down with them and to take the knowledge and put that into specification and make a digital model, a formal model of it, which you can visualize and execute and actually show how it looks. Then we start to move away from just talking what's inside the head to actually put this into a method, a product that where you can visualize things. And when you're at this stage, and the technology we use, it's technology independent. It is it doesn't care if it's ERTMS or CBTC or ATC. It doesn't care what's the end platform we're working about. We're just talking about functionality, behavior of the system. So that's what we're capturing up here. So and of course, with that capturing, then we can start to fiddle around with it and make the changes that's needed for new system. So here you're in a situation where you can both talk about the old system in one same package as talking about the new system. So here we have sort of the same methods and same way to look at the system in different stages. And again, the migration stations here is very important. So how to migrate from the old system? Extract, if you take the migration from a relay interlocking system to a computerized interlocking system, how do you do that? Yes, we can extract information from the relays and we can simulate and show how the relays is working in a computer model with the computers. Yes, and of course we could say that we like it first to behave exactly as the old system back here, and we can again show that by the computer model, and then we can start to make the changes because we have built the trust in that way that yes, we don't, when we talk about the relay interlocking again, we don't look at the drawings for relay interlocking, we rather talk about look at the model up here. And again, talking to a new system, we look at the model, we don't look at the actual software code written down here. So we need to move the level of abstraction a bit up to get to a situation where we can meet and talk to each other. So that's really what it's all about. And also another thing is where we're a bit stuck here is that many times these system, we don't really have a modularized system. Today we have a system that is in many ways really tight and built inside each other. So sort of we're here working with a system architect and sort of trying to to talk about modules and talking about how the different modules products should behave and how they should function. It's very, very important to understand in this situation to be able to actually get them to talk to each other in the next level. So again, I talked about system integrated. That role is today missing in the industry, and also say that system architect role is also quite missing. We don't, that you don't never hear a guy with that title more or less, because, and especially not a guy with that title at the IM, at the infrastructure manager, because they don't think about it as a system in that way. I know now today there's initiatives in driving for trying to get in there, but still that are on the big IMs. So it's not sort of everywhere. So I think that's a good direction to do. We need to sort of understand our system, getting control of them, and these systems in many ways they are very simple in many ways to digitalize, very simple to model, to do model and to understand. If you just could get them up here, raise the level of abstraction, not talking about the bits and pieces, the details down here. And again, like say, if we invented railways today, we never seen railways today. Of course, what we should and how we should approach it. Of course, the first thing we would do is doing a model of it. That's of course, because that's very natural to do. We shouldn't, like we do today, start building it and then understanding how it works. So of course the steps would be to do model, but that's not where we are today. Today we are in a situation we have existing system. So so then this question, how do you understand my existing system? And especially a system been around for 25 years, guys working in the left. So many times we look at system and we need to understand how they are working, and do reverse engineering more or less of this system to be able to sort of talk about them on a higher level and talk about how to actually do changes for doing a migration for new systems. So that's the sort of approach and what we're doing and trying to sort of solve and support this industry. That's the way more or less.
Yeah. I'm a bit conscious of the time. We've almost run out of time. Before we wrap up, I really wanted to touch on one other thing that I picked up from you when we spoke briefly in Melbourne at the core conference, and that was when you said that you have created almost something like a CBTC user group with different railways that your company is working with. So yes. I'm very keen on these kinds of industry collaborations. I had a recent podcast interview with Professor Clive Roberts from Birmingham, who has created a whole institute which is about research collaboration between academics and industry. So tell us a little bit about this user group, how this came about, and if you can, what kind of topics are discussed there and to what degree this is really helping the operators sitting on that group.
No, of course. This is a group that we formed a few years ago, and it's a group today where we have invited, today Helsinki is part of it, Stockholm is part of it, Copenhagen is part of it, NYCT is part of it, and we have other being interested as well. And what we do is we meet every third month, and we have sort of someone in the group present what's happening in their world and how they're approaching things. And it's sitting in this group and listening to these people, which my role in this is much being a facilitator, and my role is actually to keep the time limits because they can talk forever. So it's really about getting everybody to tell. But again, they're trying to achieve the same thing, but they all taking different approaches in how to do it, and that's because they have in the bottom and they have their old system, legacy system, and they try to introduce CBTC. But they are stuck and they need to do it differently, and they have good example and have bad example. So of course this is very interesting to share among each other. So I think that's really a good way to open up, because there's no standards and there's no silver bullet how to do this. So everybody needs to learn. So by listening and being part of that is sort of, I hope and I think and the feedback I'm getting brings value to the group and the people inside this group. And the topic is completely free for them to propose and to talk about. So it's more about that.
So is this more a presentation to inform the others what a certain railway is doing, or is this more like, well, this is what we're currently doing, we are running into problems here, and then have almost like a hot seat where others can say, I had a similar problem 2 years ago, this is what we have done about it. So is it more like a helpful discussion, or is it basically free flow, whatever happens happens?
No, I would say it starts with presentation. Then now the group is quite sort of they know each other quite good. So the discussion is very dynamic in that sense, and they get feedbacks and thoughts about it. So it's very open-minded discussion how things are working and how they approach things, and they share sort of their findings. Helsinki, for example, made a investigation of LTE over for CBTC system and share that sort of thoughts and how investigation is done. So it's a working. Yeah, it's a discussion, reflection group in many ways, but it often starts with presentation. So open-minded group. Okay. And we also do this, bring our partners and clients together in Signal and Design Automation Forum that we do every year. This year is in Paris, and it brings together the clients and partners to present what they've been doing on their different levels and tasks. So this is also a way to address this.
Interesting. I mean, every time when overseas trips are involved, or like travels from one country to the other, very often you find in government organizations that people have struggled traveling. So But generally, I think what this shows that there's a clear interest in the industry of sharing knowledge, of listening to what others are doing, and then basically comparing it to the own challenges that you have in your own railway and how to go about things. I would probably want to end this with a little plug at another way of knowledge sharing, which is the CBTC World Summit Conference that I'm organizing next month in September 20th and 21st. You will be one of the speakers at that conference, talking about a topic that I deliberately did not touch on today, so I didn't want to steal your thunder. So your company has been involved in New York as well. You mentioned this very briefly, but you didn't go into any detail, which is good because this is what will be dealt with at the conference, at your presentations there. And so for this conference, I'm really aiming for speakers from all around the world, even for people presenting for different countries than where they're coming from. So you are from Sweden, but you're presenting in the America session because that's about New York. And I have a wide raft of international speaker, a lot from railway operators, but also some suppliers involved. And I think there will be a number of very, very interesting topics. I basically picked the topics from the viewpoint what interests me with an already existing knowledge of CBTC, thinking that if it's of interest to me and piques my curiosity, then it's most likely interesting for other people as well who understand maybe less about CBTC than I do. So I'm very, very happy that you were willing to come presenting at this conference, and I think it will be very, very interesting for everybody. Well, with that, thank you very much for your time today. I thought this 1 hour or nearly 1 hour that we've done now went down way too fast, and let's see how we keep going in the future. I could well imagine that we have some kind of follow-up at some point in the future. In the meantime, I wish you all the best for the activities of your company. I think initiatives such as this CBTC working group are very, very worthwhile and very commendable. Anything that basically helps the industry elevating as a whole is very welcome. And I hope that this conference in September can contribute in a similar way, even though it's just a one-off event and not so much like an ongoing thing like your CBTC working group. So thank you very much for that, and all the best for the future of yourself and the company and the good things you're doing.
Yeah, thanks a lot, Frank, and I look forward to being part of the World Summit here in September. So see you again then.
Great. Thanks very much for all the listeners. The usual request, if you liked this podcast episode today, then check out some of the other ones. I'm pretty sure there will be more that you like from very different fields inside the railway industry, and share the news. Tell your friends about it. This podcast, I think, deserves a wider audience. And with that, as usual, keep it simple. See you next time, and bye for now.
Bye-bye.
Hi, this is Doc Frank from the studio. I want to inform you about my latest and greatest training development, and it is all about the mindset of a high-capacity railway organization. What I found in my experience of training and consulting is that often you have projects for new technology which seem to be perfectly planned, which are very well executed, and they still don't lead to the success that was expected. And very often the reason for that is mindset. Key stakeholders that have what I call a legacy mindset, an outdated old ways of thinking, where the new technology is treated in the same way as the old one, but it's just not suitable to get the most out of the new technology. What I'm offering in this training course, which is called High Capacity Railway Mindset, is that every month there's a new training module with 5 examples of an outdated legacy mindset, the suggestion of a new mindset more suitable for a high capacity railway, and how to get from the old to the new mindset. So those modules will be repeated every month for an entire year. So in total, we are talking about 60 different examples how to get from an old mindset to a more suitable new mindset. And the cost for this is only $10 per example. So this can be paid monthly, this can be paid for a year. And then you have the usual service of an alumni community afterwards, where you can ask ongoing questions for at least 12 months after the training. You find more information and you can sign up on my training portal, docfranktraining.podia.com/mindset. I hope I see you at this training. It's really leading edge stuff. Nobody else in the world is training on this. And if you really want to explore the ultimate frontier of success in technology projects, then this is the training you need to take. Hey, Doc Frank here again. How did you like this episode? Make sure you subscribe to get informed about future episodes, and check out the older episodes too, because all of them are awesome. Tell your friends about it. They will thank you for it. Thank you for listening. Bye for now, and see you next time.